All right. Well, welcome to DataPub, everybody. This is an online meetup for people who love public data sets and love to use them either in combination with one another or in combination with their own proprietary data. Our goal here is to bring different experts together and talk about best practices. So please use the Q&A button anytime during the talk, and we'll read off your questions during the Q&A sessions following each speaker presentation. We do have the code of conduct, which I'll actually stick in the chat bar, but please read this, please follow the rules, and just be kind to each other. So I'm now going to turn this over to Mike, who is CTO and co-founder, and he'll kind of give you a little opening intro.
Hi, folks. Thanks for joining us. As Nico said, I'm Mike Freedman, the co-founder and CTO of Timescale. Broadly speaking, TimescaleDB is an open source time series database built leveraging Postgres and offering full SQL. You can download a totally free version to run your bare metal, cloud account, or Kubernetes environment. Or you could use a fully hosted and managed one available on all three major cloud platforms via Timescale Cloud. But we're not actually here today to learn more about Timescale, even though I'm happy to talk about it at any time. But here, we fundamentally believe that all data is time series data. This kind of drives why we built a time series database in the first place. And we believe that there's just so many interesting, important things that you can do with time series data. And so DataPub, this meetup, this virtual meetup in particular, is thinking about, what can we learn and build on top of public data sets? Or perhaps how can we even curate more public or available data sets? And our first speaker will actually talk a little bit more about that. Because this, unlocks the value once we do so. This unlocks the value not only to developers, but also to the more general public, technical or not, given the various types of visualizations and dashboards that you could build using publicly available data. And just think how many people lately have been, somewhat sadly, looking at dashboards or visualizations around COVID-19 around the world. And we actually talked about that in our last meetup. But this meetup is perhaps looking more to the future, and it's titled OpenLitterMap, Energy Conservation and Making the World a Better Place. And it's all about public data. And we're excited to keep building this forum out where we could all benefit from one other's idea and hopefully are making the world a better place. This is our agenda today, and I would like to thank all the speakers for being able to join us. Our first speaker is Sean Lynch, who is joining us from Ireland and is the founder of OpenLitterMap. And following Sean will be John Gorman, the strategic director of Solar Network, along with Matt Magoffin, the technical director of Solar Network as well. And together, this is really about using data to improve our environment. Sean recognized that litter is a real problem, especially plastic pollution. And sometimes you don't understand the extent of a problem unless you can measure it. And sometimes viscerally by people seeing where this litter and pollution lies. John and Matt will also talk about their platform, the Solar Network platform, which provides developers with consistent APIs for distributed renewable energy management needs. And thus together, this is about how we can create a brighter, cleaner, and greener future. With that, I'll pass it on to our speakers. And Sean, this is all you.
Hey guys, can you hear me?
Perfect.
Okay, let me just share my screen. Okay, can you see that? Can you see my screen?
Yes, perfect.
Yeah, good. Okay, hi everyone. My name is Sean Lynch. I'm the developer of OpenLitterMap, open data on plastic pollution with blockchain rewards Litercoin. So I'd just like to start by thanking Timescale for facilitating this event and for bringing everyone together. And I'd like to thank everyone who's joined for taking an interest in open data and open data on plastic pollution in particular. So just to give you a background about me and how I came up with OpenLitterMap, in 2008, I started studying geography in university, and I was introduced to GIS, Geographic Information Systems, which is software for making maps and analyzing spatial data. And I was asked to write a dissertation in 3 years' time, so I started thinking about what could I apply GIS to. The most obvious thing that I could think of at the time was to use GIS to communicate this area near where I live that's plagued by dumping and littering and antisocial behavior. And I wanted to use GIS to communicate this to society to change behavior and to try and use the data to get it fixed. When I started doing the research on mapping dumping, I quickly realized that there was like micro litter absolutely everywhere. And as soon as I noticed that, I couldn't stop looking at it. Everywhere I went around the world, I found litter in all corners of the globe. And during my travels after college, I ended up scuba diving in Thailand, which was a remarkable experience. And there I really became accustomed to the problems of plastic pollution in the oceans, and also the significantly untapped human potential of data collectors that we're just starting to scratch the surface with. And I'll get into that in the talk. So after doing a bit of traveling, I came home and I did a master's in GIS to try and get these skills in mapping, and started digging more into the research and the literature around litter mapping platforms. And in 2013, during my master's, I was introduced to OpenStreetMap. And this introduced me to the world of open data and its unlimited potential. And I started reading literature about OpenStreetMap. And walking home from college that day, the day I was introduced to OpenStreetMap, I had my phone in my hand and a light bulb went off, and I realized there was no way for me to actually use my device to put data on a map, but for also to make that data accessible to try and mitigate the problems of plastic pollution. So in 2013, the day I was introduced to OpenStreetMap, I decided to apply the same principles of crowdsourcing and open data to plastic pollution, and OpenLitterMap was born. So to give you a small bit of context about plastic pollution before we dig into OpenLitterMap, citizen science, and open data, plastic pollution is strongly recognized as a significant marine problem, and it really is, but it doesn't originate in the ocean. Most of it originates on land where people live. And although there are significant marine implications, if we want to try and mitigate plastic pollution, we need to go upstream and communicate it where people live, in their backyards, right outside their door, and advance how we characterize plastic pollution, not as a marine issue, but we need to start looking at its pre-marine terrestrial origins and communicating and characterizing it in people's local contexts. So a bit of background information about plastic pollution. Plastic pollution, as far as I can tell, was first recognized to have a global distribution in the oceans as early as 1975. By 1975, researchers first recognized that this is now a globally distributed phenomenon in the oceans. Nearly 50 years later, by 2010, a study by 𝗔𝗵𝗽𝗀𝗃 et al. Recognized that, or extrapolated, inferenced that based on population figures and waste management metrics, there was about 8 to 12 million tons of plastic pollution entering the oceans annually as of 2010. On average, every hour, that's about 916 tons of plastic that are going into the oceans every hour. However, many authors recognize that there are large uncertainties with these figures because of a lack of data. So they're using population and waste management metrics with a little bit of data, but there's not much actual data to tie into to improve those figures and understand how plastic is moving across space and time. So a lot of the plastic is due to single-use plastic packaging and very poor waste systems and education. Litter, before it becomes plastic pollution, once it's just dropped in the streets, when it's still fresh, costs taxpayers millions annually. Your money that you pay in income tax and everything else is just being spent running around in circles, picking up this unwinnable war against litter that's costing the environment trillions, and it's wasting taxpayers' time and money. And there needs to be room for intervention to try and mitigate that, because that money could probably be spent on better services like healthcare and homelessness. Litter is also responsible for the deaths of hundreds and thousands of birds and marine mammals and marine species around the world annually. It's currently estimated to be, there's about 150 million tons of plastic that's currently rotting in the oceans. It's not productive. And a lot of the plastic that's entering the ocean hasn't even started to break up into microplastics and nanoplastics yet. So a lot of the plastic that's currently, or a lot of the microplastics that are washing up on beaches around the world are from the marine litter in the oceans that's been degrading probably for several decades now. And a lot of the plastic that's gone in recently in the last decade or two hasn't a chance to break up yet. And we need to extrapolate into the future and make inferences about and projections about what future microplastics and nanoplastic distributions are going to look like. Plastic pollution is also expected to get exponentially worse if current trends continue. But there's room for intervention to change things, to change people's behavior and understanding about how badly polluted the world is and what we're going to do to fix it. Our knowledge of how badly polluted the environment is, I would suggest, is significantly underdeveloped. And it only really started to become more developed when social media became popular, or when millions of people joined social media, because this enabled the easy sharing of knowledge transfer. No longer were we dependent on single sources of news for how badly polluted the planet was, for example. And there's implications to that as well with fake news and everything else. But once people could start to share information and consume information accessibly, this led to a mass awakening of permanent global pollution. And this is why everyone suddenly started talking about plastic pollution. Even though it was long recognized to have a global distribution in the oceans 50 years ago, this information was locked up in silos and research papers that you needed a PhD to be able to access. But social media made sharing information very accessible, and that distribution and that democratization of knowledge production led to a mass awakening of pollution. And citizen science will do the same thing. Just as social media made it easy for people to share information, citizen science needs to become more developed to allow people to share data as well. And that'll have a similar impact just on how it'll change just how we perceive and understand how badly polluted the planet is, which is not developed. And one of the positive things about plastic pollution and citizen science is that data collection has a very low barrier to entry. So up until recently, citizen science was typically done for biodiversity, but you needed a PhD in ecology to identify a bee, whereas litter mapping has an extremely low barrier to entry. You don't need to be an expert in anything to be able to identify a plastic bottle or a cigarette butt, because it's the products we use every day. So as well as its accessibility, its abundance and its distribution, it just makes engaging with citizen science very accessible for the majority of people. And up until coronavirus came, I would suggest that litter mapping was the most accessible form of data collection the world has ever seen. Now, I'd say corona symptom mapping is probably more accessible, and I might finish on that. So to try and mitigate plastic pollution, I've invented OpenLitterMap, which is a citizen science platform that allows people and empowers people to map, but also share data on plastic pollution and litter anywhere around the world. The data is accessible for anyone to download as open data by country, state, or city. However, how to create value from that data and actually what to do with it is very new and largely unexplored. And it will continue to remain unexplored when access to data is restricted. So I'm trying to empower society to share data and to enable the development of a democratic research community who can use this data and actually create value and solutions from it. So businesses can use it for commercial purposes. Students can use it for their homework. Researchers can use it to improve policy implementation and targets and everything else. So to give you just a little bit of information about OpenLitterMap, it's new. It's also quite underdeveloped, but I'm trying to build a superior data collection experience, trying to make it really fun and easy and engaging and rewarding for people to share data. I call it like it's like Snapchat for litter, or here in Ireland, we've got Tidy Towns as a cleanup group, or I call it like Pokemon Go for Tidy Towns. It's backed by over 10 years research, including 2 masters, and the data is accessible as open data, so anyone can download the data and actually use it. In terms of the software, I'm using Laravel as a PHP framework on the back end. I use Vue JavaScript framework for the front end. I'm using bullmap.io as a CSS package for styling. I'm using React Native for developing mobile apps, And I recently launched version 2. I started with 𝗥𝗲𝗃 for any developers, recently exported from 𝗥𝗲𝗃 into pure React Native, which is much more stable, still a couple of bugs that need to be sorted out. I'm using Ethereum for tokenization. So OpenLitterMap is the first platform to reward users with tokens for the production of geographic information and the production of open data. So we took the proof of work principles from Bitcoin and we're applying that to citizen science for the first time. So as you play the game, as you do the work, you're actually earning tokens, and I'm trying to create an economic incentive for people to collect data and then to gain access to sustainable products. I'm also using TensorFlow for machine learning purposes, such as object detection and prediction, which is pretty new to me, but that's kind of that's my plan for the summer. Using OpenStreetMap as tiles, as you can see, which is all open data, Leaflet for web mapping, and Turf for analysis. Up until now, OpenLitterMap has been almost entirely self-funded on my behalf. I've probably spent at least 100,000 euros, and if I had more, I'd have spent that too. We're not yet open source. Once we achieve minimum viable product, we'll be launching the code as open source, but I'm looking for co-founders at the moment. So if anyone's interested and has some of those skills that I just mentioned, several co-founders are available. Drop me an email or take a look at yourself at OpenLitterMap at Angel. So here's just a couple of screenshots of our mobile app. On the left, you can see that it's just an empty photo gallery. You can press the photos button and you get access to your geotagged photos. You then select the photos that you want to include and they'll appear on the left in your photo gallery. Once you have photos ready for tagging, you select a photo and you'll open the right-hand menu here, which is a litter picker. You select the category from the top, be it food or coffee or alcohol-related waste, and at the bottom you get a list of pre-populated, predefined tags based on the category that you selected. You use the orange button to add an item to your collection, be it a plastic water bottle or however many number of cigarettes. And as you're adding more data, you're helping our machine learning algorithms to train. So in the future, this will hopefully all be automated. But to generate that data, to train those algorithms, we're currently crowdsourcing that manually. So then you press the green button to confirm, and you'll be on to the next image, or that window will close and you can press the upload button. And when you upload, you're creating open data, and anyone viewing the global map at openlittermap.com will see live events of anyone uploading. So if you're uploading, anyone looking at the map will get a live feed of photos being uploaded from the location wherever they were taken. So there's the global map. If you click on World Cup, and I'll show you this in a minute, you get a list of countries. If you click on the name of a country, that's a link. You get access to the list of states within that country. And if you click on the name of a state, it's also a link. You get access to the list of cities. And the reason we do this is because we drill down to the small town or city level. And with that, when we load a smaller amount of data, we can render more sophisticated maps, and we can do a lot more with it in the browser. So you're looking now at a small region of Puerto Rico, where one of our super users uploads data nearly every day. On the right-hand side, you can see that you can toggle the litter by behavior. So currently the soft drinks category is selected. You could turn that off and you could look at a snapshot of how alcohol-related litter is distributed in that neighborhood. And these maps are very powerful tools because they reveal to us what has become normal and invisible for many. Many people see litter every day, but they've become accustomed to it and it's become normalized. By mapping it, we can change people's understanding of how badly polluted their environment is. It's not an Asian problem. It's not just an ocean problem. This is literally in your backyard. And just as when Google Earth was first released and people could look at their homes from space for the first time and it made exploring maps fun and interactive, litter maps are similarly quite powerful tools that have potential to change human behavior and actually stop littering from happening. However, litter maps, although powerful, pale in comparison to the unlimited potential of open data. Litter mapping is new. It's also largely unexplored. So there's all these new forms of data coming along, but not many people, society in general, doesn't really know yet how to create value from this data. So we're looking for people to actually start using this data and finding solutions with it and pioneering science and how to create value from this data. I would suggest that the more polluted something is, the more open the data should be. And you should ask yourself, what's the alternative to open data on pollution? If we decide to actually restrict access to data on pollution, who gets to create knowledge and solutions, and who gets a license to produce, our knowledge and understanding of how badly polluted the environment is, or who gets to find solutions? And I would suggest that the best way to go about it is to give everyone equal and open and unrestricted rights to access and use data for any purpose. And this is particularly true of pollution. Many people are new to collecting data. Litter mapping, as I mentioned, has a very low barrier to entry, which is great. And lots of people can now participate in data collection for the first time who previously weren't or didn't have that accessibility. However, there's many apps out there that restrict access to data, and they want to control who's allowed to use the data and control what that data is allowed to be used for. And many of these people, the majority of our users using citizen science apps, are new to data collection, and they don't question the implications of restricting access to data on pollution. I find this incredibly problematic. Open data, it's better for institutions. Trust in institutions in many regions is at an all-time low. And by simply embracing open data on pollution, institutions, our public institutions that we pay for through our taxes, can gain better social capital. Open data, I would also suggest, is much better for the economy, because companies like Timescale can use it and create value from it and create jobs and lower public expenditure and improve services. And that's not just limited to one company, but all around the world. Businesses, society, researchers can work together openly and transparently without borders. And our goal should ultimately be to eradicate or at least mitigate pollution. So as I mentioned, we need people to start using our data, and we're looking to develop a research community. And we need people to start exploring and pioneering these new forms of data and science. Citizen science is social media 2.0. With social media 1.0, people could share information, text, videos, images, whatever. And this, as I mentioned, led to a mass awakening of global pollution. However, social media 2.0, citizen science, allows people to share data but remains unsupported. Knowledge production, how we know something in society, was traditionally the production of knowledge in society was a very top-down process. It was the people with the PhDs and the money and the news organizations who created knowledge, and it kind of trickled down to everybody else. And in terms of pollution, a lot of knowledge is being produced by producers of pollution who run various cleanup organizations. And citizen science and open data in particular reverses this paradigm, and it changes the top-down production of knowledge to a bottom-up one. And this is still very new and largely unexplored. I would suggest as well that open citizen science data in particular is an important catalyst for the environmental movement. Currently, this is so new and unexplored, and it has potential ramifications. And it's very important that as more people get involved with citizen science, that they're encouraged to question who is allowed to use this data and what restrictions come with it. And I think that's an important point just for the environmental movement as things progress. And I also think that it's very important that just scientific progress and legal progress more generally on pollution in particular is an open, transparent, auditable, and democratic process. This is particularly important for pollution, as I said. And how we characterize plastic pollution, if you ask most people how they, what do you think about plastic? What do you know about plastic pollution? There's 10 rivers in Asia, and there's a lot of plastic in the ocean. There's 5 gyres, and that's not wrong, but it doesn't account for plastic pollution. It's everywhere. And it sort of shifts the blame to the east or to elsewhere, somewhere else. It's not my problem, but it is in your backyard. And we need to start unraveling how badly polluted the environment is, and how does plastic and litter transport over space and time. These are things that we currently don't really have a good grasp on. So as where was it going here? So yeah, our next steps. Where are we going next? I'll be launching a GoFundMe later, probably this quarter or next quarter, and I'm hoping that people might share it and chip in a few euros so we can actually, or dollars, so we can actually develop this platform. I've applied for 60 grants in a row, which were all rejected. So I'll be applying for my 60th to 70 grant applications over the next couple of weeks. I'm looking for co-founders. I'm looking to build a community across Slack, Facebook, Telegram. You can search for it on Google or send me. For me personally and professionally, the next few months, I'll be getting a handle on machine learning and smart contract development. And using LitterCoin, I want to create an economic incentive for people to share data, and also for businesses because they can attract new customers into their business. Together with this, I'm looking to achieve a minimum viable product. And once we have that developed, once I've got a handle across the stack, the platform will be released as open source so anyone can participate. Later on, once we achieve MVP, I'm interested in making the data immutable, potentially using blockchain or distributed ledger technology. And I think that pollution is one of the largely untouched areas of blockchain that's really important. And there are significant energy implications with the blockchain stuff, and I'm aware of that. And it's not urgent. I'm waiting for proof of stake and potentially, much lower energy costs. But I think it's important that data on pollution should be immutable because the likes of Trump or China won't be able to delete it. We'll also be organizing our first conference, Stop, the State of Plastic Pollution, where we'll invite researchers and data enthusiasts and activists from around the world to use our data and to share best practices. Once this is all together, I believe that it'll lead to the most rapid production of open data the world has ever seen, potentially leading to the production of global data in minutes, and ultimately leading to a democratic research community who can ultimately mitigate pollution, save lives, resources, time, and money. So there are my slides. I don't know how I am for time. I've got I could show you the web app if we're stuck for time, but thanks very much for listening to me. And I hope you'll join us and share data on plastic pollution.
Thank you so much, Sean. That was great. Does anybody have any questions they'd like to ask Sean at this time? Please use the questions bar. If not, we'll give people like a second, but also we'll do a follow-up and gladly share Sean's Twitter handle. So if you guys do have any follow-up questions about this, please feel free to reach out to that.
Hey, I had a question, if I could.
Oh, yes, please.
Yep.
Hey, Sean.
Hi, Matt.
Loved your talk. Loved your enthusiasm. I wondered if you had thought about a sort of follow-on aspect of just the collection and categorizing of all that litter data, but to actual cleaning it up. If like you thought that people just taking the photos of it might also be involved with picking it up, or if you might tie in to sort of city councils and stuff to feed them possibly in real time those sort of snapshots of litter with the hope of somebody coming around to pick it up.
Yeah, absolutely. That's part of the plan. The platform is still significantly underdeveloped, and I'm still fixing, front end mobile app bugs, but ultimately that's kind of direction we're going to have to go down, and that'll create even more value as well, but not there yet.
Excellent, thanks.
All right, great. Any other questions? Wait, okay, so Eduardo asked, any ideas on how to migrate the effect of malicious people uploading bad data?
That's a very good question.
Yeah.
And in my experience so far, first I'll say that at the moment, we manually verify all of the data that comes in. So when people send us photos, we inspect photo and data, and most of it is just confirm, confirm, confirm. 99% of users do a very good job. and submit data perfectly. A small number of people are a bit lazy, and that's okay too. We correct their data, but we haven't found anyone yet actually uploading maliciously. So maybe in the future, but even if that does happen, it'll be negated by the overwhelming variety of high quality data that the majority of users are creating. But we'll, in the future, if things grow exponentially, as I hope they will, we'll have bots and stuff in place to classify any potentially malicious uploads. But very good question.
All right, perfect. All right, so if anybody likes to reach out to Sean, we will be sending out a follow-up with his Twitter handle. So at this time, Sean, if you could stop sharing your screen, and we'll go over.
Sorry for going. Yeah, thanks.
No, perfect. And so now I'll have John and Matt take over from Solar Network.
I will just share my screen. Oh, thanks everybody. Sean, that was really inspiring. That's a totally compelling idea. I'm very excited to take a look at that. Thanks again, Lacey and Nico, for having us, and Mike. It's great to be part of DataPub #2. I'm going to be speaking about Solar Network, which is a Solar Network Foundation, is a nonprofit in, so talking about Solar Network, which is both a nonprofit here in New Zealand and also a software project, open source software project we've been working on for a while. We were founded in 2017, but we've been working on this software project since 2008. And it really all started in a playground in Auckland back in 2008. Turned out Matt and I were both Americans living in New Zealand. I was from the East Coast, Matt was from the West Coast, and we got to chatting as the kids were playing in the playground. And Matt was an enterprise software developer with a strong interest in environmental issues, and I was a solar IT guy trying to do some software for my master's thesis, and we started talking about it. And so Matt really said, oh, let me see what you're trying to do here. And he's like, oh, okay, I see what you're trying to do. I'll try to do this. And we started to work on something that was basically grabbing information from different brands, different pieces of equipment that produced, that was involved in solar data. And that's really where it came from, the solar side of it. And we've had this ability to produce a platform which is, we've had the luxury of really producing a platform which has been thought out carefully and done in a good way. And we're really driven by the idea that open source is a catalyst for change. And it's really about that enthusiasm and the transparency of the open data and the community of people working on it together that can be that change. So that's really where it started. And we'll just go through what we offer. So basically we have a cloud-based software development platform, which has a RESTful API that you can use to both store your data and retrieve it. We built it as an 100% open source, mostly Java-based code base. And this is all about acquiring data from different pieces of solar equipment and other equipment and other software services, regarding energy flows and being able to present that in visualizations and analyze it. So we offer a whole set of tool chains and utilities, documentation, example code, and clearly lots of friendly advice from people who've been doing this for a while. And that's what the Solar Network platform is about. And, now, in terms of the data that we collect, we use TimescaleDB, and basically due to its JSON data types, we can really capture anything. So it's, although the name solar started out with capturing information from solar devices, which we do, we really can take time series from a whole bunch of variety of different things. So, you know, we capture high resolution data in regard to energy coming off solar arrays, what kind of power you're using in your house or business, the amount of sunshine in irradiance from pyranometers, the weather down to the wind direction, and the temperature, air temperature. We track water going through water meters, location, and energy prices off the network and the different tariffs involved. So these are all things that can be combined. And I think it's really it's a synthesis of all this different data that I think that leads to new innovations and new ways of doing things. What Sean was saying too, breaking down silos, that's a big part of I think the innovation that we can unlock. So let me just go over a little bit about the platform in general. So the main thing that we offer really is a RESTful API to what is SolarNet, which is our server. It's our repository hosted in the cloud on AWS now, and it's quite a complicated system, which we can detail later. But essentially, it's the cloud server where all the data is, and has a whole bunch of support services around that. And then we have the other piece of component really is the Solar Node. Solar Node is an on-site data acquisition client, which can be run on a very small, low-power device. It basically is, I always call it the Swiss Army knife of data acquisition, because it can really talk to lots of different things and grab that data, persist it, and post it up to SolarNet. And then you see on the upper left, the Solar Console we have visualization APIs. So there's lots of different ways you can visualize that data once it's up in the cloud server. And so the Solar Console is an example of once the data is up there, can I see it and chart it? And then we have some experimental, clearly what Sean also referred to, that, you know, obviously machine learning is something to analyze the data, and there's lots of different methods there. We're not saying we're machine learning experts, but there's certainly an opportunity there to take a look at that data, you know, look at it, analyze it, and then act on it. And I think that's a big part of the platform really, is that it's not just about persistence and data acquisition, it's about being able to actually control things and control energy flows in intelligent ways. So Solar Network, the API, allows you both to grab data from different devices, and also you can actually control them. You can send them control signals independently of the device, or have the device logic be reacting to this information. So that's where the intelligence comes from. We think there's some real opportunities there. So we speak to lots of different pieces of equipment. And I think that's a big part of this, is that, you know, there's been silos and ways that manufacturers or software providers they can offer monitoring services, they can offer different things, but they don't necessarily play well with others. And what we're saying is we really want to connect to everything and anything And we've taken this plug-in framework, which is very flexible, and we have implemented connections to all the major pieces of solar equipment, and I think that's a big part of being able to come up with these new solutions. You know, possibilities really open when you can do that. The API, the way we interact with our cloud network, once the data is collected from these devices and is up in the cloud, is standard RESTful API, and I think Matt can answer more questions about that. But it's really about consistency and having a congruent kind of vision of how people want to grab these time series so that they can visualize them or analyze them. So your main interface to Solar Network is what we call a Solar Query, which is the RESTful API. And so there's lots of applications you can do with this. Might have started out with solar generation monitoring. You know, you want to see how well is your solar panels, how well are they doing, and then you'd want to know how much energy your house is using, so that we can hook into different meters. We can also remotely control things. So you can send things control signals based on logic at the client level, or a centralized command that comes from SolarNet, or a combination of the two. So there's lots of opportunity there, and we think there's applications like demand response. You know, as the world moves towards more renewable energy, as that's a greater share of the energy being used by businesses and homes, you know, being intelligent about when you use that energy, the time series aspect is really important. We hook into EV chargers using a standard called OCPP, the latest interface. So there's a lot of electric vehicle fleet management applications to be done, and I think the cross-device nonlinear analysis is another thing. Is that we really want the idea that, you know, however you want to analyze your data, but you can find patterns in data and then intelligently respond to that, hopefully in real time. So let me just give you, you know, we're really about being the back office. We're really about providing tools to people. And, you know, as 𝗵𝗽𝗱, I think, said, you know, if you don't look good, we don't look good. So we're really about having application developers produce amazing things and being their support staff. So one of the companies doing some amazing stuff for Solar Network is 𝗥𝗲𝗃. This is a very advanced, smart group of visionaries in Brooklyn, New York. And what they do is they own and operate a set of assets. They call them DERs, not to bring up an acronym, but distributed energy resource. So that's commercial solar arrays and storage. And basically they had a situation where they were looking at a legacy set and a new set of assets across the United States, across the East Coast. And they really needed a way to manage all this different data and break through the silos that each manufacturer brought up. So they're building what is really this is the next generation of electricity utility, and that is that's an amazing application where they're taking distributed assets that they own and operate, and they can just own and operate these assets much more efficiently, all under one data umbrella. And they've got just a beautiful piece of software underway to manage all that. So it's very exciting. Another example is here in New Zealand, there is a team of people who have built essentially a city or a small, it's an eco resort called Camp Glenorchy. And this, I don't know if if you ever have the chance to go to the South Island of New Zealand, Camp Glenorchy is just a breathtaking place. And basically it's a very well optimized, this has been done by the top high performance building designers here. And so everything about this little campus of buildings, their energy use, their water use, their booking system is tied into it, but essentially runs on solar network in an optimized way. So it's the kind of thing where if you make a reservation to stay here, you know, your cabin will automatically go to the right temperature based on the time when you're gonna arrive and that sort of thing. So it's what this really illustrates is that the visualizations you can get and the analysis you can get doesn't just involve solar energy. It can involve, here they track the water use, they track a lot of different things. And that's all to do with the flexibility that Timescale gives us with particularly the JSON infrastructure and data types. Some more screens about that. But this is, yeah, so this is really a very advanced community in the South Island of New Zealand. We're really into education, so we really want kids and students to understand renewable energy and understand the context of renewable energy in society coming up. So we work with, our software supports a bunch of different initiatives to teach kids about solar and energy use. And these are some applications which you'll see in the resources. You can see the live versions of these. But these are solar schools where there's a solar array in the school, and you also have the consumption of the energy by the building, and you can see those together. Just to give, Matt, you can chime in when as needed, but just to give you a little background on our implementation of Timescale. We're hosted on AWS. It's a Postgres 9.6 using ZFS file system, and we're at 300 gigabytes, but growing. But being compressed, it's very manageable. And we basically we actually came up, or I think we developed the idea of aggregates in order to speed up queries. Because often people are going to give you an ad hoc time range, and you don't want to be going through that in real time. So to pre-compute those is a great idea, and it's something we love about the features of TimescaleDB. Just to go over some of the advantages of Timescale, how it helped us, just the table partitioning options let us grow and adapt as we got bigger. And that's really something that we couldn't do with other products. We love the Postgres solidity and everything that came with it over the years. So we're very comfortable with that. We're also, we have a lot of opportunity to bring data, historical data that hasn't been on the system in. And so that ingesting of data is really helpful. Clearly the Timescale team has been so responsive and helpful to queries. So that's just, the support there is just outstanding. And it's just very memory and resource efficient. So we can spin up instances and try things out. And we're excited about the aggregation, for example, and new features coming out. We implemented that in a different way to begin with, which Matt can talk about, but this is something that we're looking into, so it's great. Thank you so much. I'll leave these links up and can take any questions.
I can answer that question, Francesco. Yes, we have looked into, we will eventually upgrade to a new version of Postgres. It hasn't been a really super high priority for us at this stage because Timescale is doing the things that newer versions of Postgres started to implement already. So primarily we're getting that good partition support and sort of like query partition pruning via Timescale already. I know it's much improved and there are other features in newer versions of Postgres that we hope to leap to. I think when we started SoNetwork, we were on Postgres 9.3, and then we waited around until 9.6. There were some compelling features there that we jumped versions. And I've been thinking, you know, that was 3 major version jumps. So the next one we might jump to might be 12. But I do like waiting around because the new features that come out with newer versions of Postgres are always great. So it's almost like the longer we wait, the better things will get, as long as there's not something holding us back. And at the moment, there's not really anything holding us back.
Great. Anybody else have any questions at this time? Yeah. Well, we have, we're able to share like Solar Networks GitHub handle after this is done. So if you have any questions, please feel free to reach out to them, or you can also get in contact with them. But once again, thank you to our speakers who gave this talk at 9 p.m. at night in Ireland and 8 a.m. from New Zealand. We definitely appreciate it. Thank you again for joining us today. Please let us know if you'd like to present at a future meetup. And our next meetup will be on May 19th. So thank you again to our speakers. We'll send out resources and this deck in a follow-up email. But yeah, thank you again to everybody.
Thanks, Nico.
Yeah, thank you. Thanks, Nico.
Thank you, guys. Thanks, everyone.